Hello, everyone. We're the group working with the analysis of ransomware activities. My name is Joel Watlington.
My name is Christopher Lewis.
And I'm Nick Stone.
All right, and with that, we have the problem statement. And so, with ransomware, ransomware causes millions worth of dollars in damage every year. In fact, WannaCry, when it first came out, or worldwide, cost $4 billion worth of damage over the course of its time. And so, with that, detecting ransomware can help mitigate and prevent harm to a system, but we won't necessarily be looking at that since it's kind of out of the scope of our project today. But our goal is to help kind of analyze different SMB logs and kind of like compare the different ransomware families. And so an SMB log essentially is the command control that ransomware has when it comes to the attacker. For instance, an attacker might use 0 to negotiate, 1 to create a session, 5 to create a file, 8 read file, and 9 write a file as different examples. And with that, I will move it to pass it on to Nicholas Stone.
So a lot of our work came from this page where these guys did some research on ransomware by running them in a controlled environment and produced SMB logs for the different transactions. We've collected over 80 ransomware logs from this website. They also wrote a paper, like I said, detailing how they did it and what kind of environment it was ran in. One of the first steps we set off to do was to just clean the data and make sure that we can narrow down the columns that we thought were the most useful. A couple that were important are the timestamp, which tells when something happened, the SMB command, which is what Joel was talking about earlier, the actual command that was being run, and the session ID columns, which help us track which session is currently being run, because sometimes a ransomware may spawn multiple different processes. And then next, we took the logs and wrote some Python code in a notebook to analyze the logs with the end goal of being able to visualize different aspects of it. For visualization, we mainly chose both the pie chart of the different SMB calls that were made, as in this example below, and a histogram that shows the frequency of SMB calls made over time. With that, I will pass it off to Chris to actually show off the code.
I'm going to be going over a walkthrough of the code that we made to analyze the ransomware logs. So instead of hand waving all these functions that we made to you, I'm just going to show you how they work. We'll start out with the 24th one right here. So first, it reads in data from a TXT file that we got from the logs. So this is why I had it already pulled up. But as you see, this is not very readable. So we made a function that will read it in, and we also will clean that data right there, remove any acknowledgments from the server, and remove any sessions ID that weren't made by the ransomware log. And you can create an SVG file. That way it becomes easier to read and more visible. You can see all the different SMB commands that are made. And it makes it like very clear what the ransomware is doing when you manually review the logs. But we want to be able to see what the ransomware is doing on the macro scale. So we made different charts to help visualize what it's doing. So we have a pie chart that shows like the percentage of calls that is made by the ransomware. We have a frequency chart that shows like the frequency of each call. So this one right here is the crate one for the revenge sample. You can see a lot of crate also means open. So there's a lot of files being open at the very beginning, but not at the end. So that means maybe they're doing smaller files right here. We can check by seeing how many reads are also being done right there. So try that, run it again. You can see the reads are way up at the end, so that confirms my suspicion. And we make box plots of the different frequency calls and do stats on it to help try to visualize like how often that each one gets called and what's the average, median, and all that. And then lastly, we made it where we can compare different groups. So we combined all these data together of 10 different samples and of the read or of the write call, and you can see the frequency over time, and it kind of goes down over time because the ransomware tries to get it done as fast as possible. And then you can compare the different frequency calls between each group. You can see the global imposter, it does the most write calls and the most read calls of all of them. And then we also made a function that tells you how many files each one accesses. And just so you can see, like, oh, does more read calls necessarily mean more files accessed, which the answer is no. You can see, because it doesn't really correlate very well. And after that, I'll pass it on.
After running the type of code that Chris showed earlier, we were able to observe different patterns that ransomware have. For example, some ransomware will encrypt files in a particular order, just going from the top to the bottom, while others will prioritize certain important folders first, say the documents. One observation that was pretty consistent is that all ransomware will make a lot of read and write SMB calls. And that means that looking for something like this is a good way to potentially identify different kind of ransomware. And with that, we are finished. Does anyone have any questions?